So hello everybody, welcome back to episode 3. So now we will use the logical volume manager and not directly mount a partition as in the last episode. What's the reason for using logical volume manager? This actually has a couple of big advantages, especially when we work in a production environment, when we provide file services for our employees. One of the problems of the partition is that a partition has to be as a contiguous space on disk, so you cannot split a partition for somehow because the file system requires a block device, the entire block device. But what if we want to increase the size later? The problem is if you have more than one partitions, and when the first partition is too small and then we need to extend this somehow, we cannot jump over the second partition. We have to make sure that everything is as a contiguous array of bytes, and this LVM gives us much more flexibility compared to the basic partitions. So that's the basic idea. First of all, let's talk a bit about the idea of this logical volume manager. So how this actually works like and what's the basic setup. So that's the idea. So a small slide to give us an idea about what we can do. Remember last time we used the SDB1 as a disk, then we formatted it and directly mounted. But now we use the LVM, and the idea is we have 3 steps in order to now create block devices out of existing disks. So these 3 steps are the physical volumes, the second step is the volume group, and the third step is the logical volume. So these are the basic commands. So for LVM we have a set of 3 classes of commands. One work with the physical volumes, one with the volume group, and one with the logical volume. And this is now actually what I want to do right now. Instead of using SDB1 directly, I create a physical volume out of SDB1, which means make it available for LVM. Then we create a volume group, which gives us a management unit. And the idea is when we create a volume group, the entire hard disk is split into those PEs. P stands for physical extents. A physical extent is a number of sectors. So the basic unit is a sector of 512 bytes. While a PE is normally I think is 16 blocks, so the default size of this PE physical extent is I think 8 kilobytes. We simply can think about to split the entire disk into these chunks of physical extents of 8 kilobytes each, and then we can create a logical volume out of it. Which means I say, okay, even though I have a disk of 500 megabytes, I need only a partition of size, let's say 200 megabytes. And then this logic volume manager decides how much physical extents are necessary for my newly logic volume, and then can assemble these PEs together, making up a logical volume, which is then exposed as another block device to the system with another name, of course. We simply replace the name SDB1 then with the name dev VG0 LV0. This first is the volume group and the second is the name of the logical volume. And then you can use this the same way as if it would be a block device. Be formatted and mounted. That's the same operation as before. So that's actually the basic idea. What I want to do is first create a physical volume, create this volume group, create a logical volume, and then we can format it and mount it. So this is the basic operation for the logical volume manager. So what do we need to do there? So first of all, we need to create a physical volume. So here we are in our virtual machine. That's the same setup. Remember, when we do parted-L, we will see parted-L, we see this previously generated partition SDB1, what we formatted and mounted directly. But now I will convert this thing into a physical volume first. So first, for LVM we have these 3 classes of commands. The physical commands start with PV, physical volumes. So when you type in PV and press tab twice, I press tab, You see all the commands which starting with PV. This is for virtual, for physical disks. Then we have the command starting with VG, volume group. Again, I press tab twice. So these are the commands for volume group. And then when you use LV, press tab twice. We see all the logical volume commands. We don't need all of them, don't be afraid. We only do this step by step. So the first thing what we need to do is we need to create a physical volume, which means make this thing available to the logical volume manager. So the command is pv create, physical volume create. And here I have to give it the name of the block device. Again, I could use the entire disk for physical volume, which is possible. But I will not do this because otherwise this parted will complain about not knowing the partition table. So I use the def SDB1 instead, the partition, which wastes a little bit of space at the beginning for the partition table, but this is okay because we still have the entire disk for the physical volume. So this is how you create a new physical volume. It gives me an error because previously I formatted this with ext4 file system, and now it recognizes it's not empty anymore because there's something on it. It detects this is not empty, because now if I say yes, I will overwrite this current format. Remember, we created a file on it, this hello world file, which is now then wiped from the disk because it's then gone when I type yes. So every data is lost. Be careful when you say yes, everything is lost, but because we don't need this file anymore, we say yes, I can wipe it please. And then that's it. Now we have a physical volume. And now this thing is attached to the physical logical volume manager. It's always a good idea to look at what's being done, if this was correct, and then we always have those display commands. You see, we have the PV display, we have the VG display somewhere, VG display, and we have the LV display. We always have these display commands in all the three levels. So let's have a look with PV display, physical volume display. This gives us a list of all physical volumes. We only have one right now. It says okay, def SDB1 is a new physical volume. It's about this is the size. And then the total PEs is 0. It's still 0 because it's not member volume group yet. This splitting into PE only happens when you add this to a volume group. It's only, don't know what to do right now. It's simply attached to the logic volume manager, has a UUID and has a couple of has a basic size. And now the next thing what we need to do is we need to bring this into a volume group that we can actually use this for a logic volume. Which means the next step is we create a volume group. This is called a group because a group can contain more than one physical volumes. That's actually the basic idea, that we can attach more than one disk. Okay, so let's create the volume group. Volume group create. We give it a name, anything, volume group 0, can be any name, and then we add a physical volume. This newly created physical volume, this exactly this name, has to be added there. Volume group create. Again, it says now volume created successfully. Now what's the difference? Now let's again have a look at the physical volume first. PV display, physical volume display. Now you see a change. So you see this changes. Now it says 0 PEs, and now it says total PEs 124, which means now we have 124 physical extents, which can be allocated to logic volumes. Free PEs is the same because nothing assigned yet, so everything is free. So this is because we have those two numbers. So this is the physical volume. Now let's have a look at the volume group. Again, we have this display commands, volume group display. This gives us an idea about the volume group, where this physical volume is member of. So this is the name, a couple of informations. The size is of nearly 500 megabytes. This is the total PEs from our physical devices. That is of course the same because nothing allocated yet. And everything is free. It has also a UUID. Of course, the idea is later then we can add another physical volume to the same group, which then adds more PEs later then. But for now, it's free. Everything is free. And the last step, the third step, is now we create a logical volume. So we take a couple of the PEs. I will not use all of them on the beginning. And we can assign a logical volume out of it, which is a subset of the PEs. The big advantage is now, even though on the physical disk this is not as a contiguous place, from the logic point of view, the driver sees again a block array of blocks which can be indexed from 0 to n. So now let's create a logical volume. The command is LV logical volume create. Now we have to give it a size. The basic size is 500 megabytes. I use only, let's say, 200 megabytes, not creating all the space. Then I use a name for it. I name it LV0 for logical volume 0, and of course I have to tell which is the volume group where I want to create a logical volume out of, volume group 0. So this now creates a logical volume created. Now let's again look at all those different places. Let's start with the physical volume first, physical display. So what's the difference now? You see now the total pieces has shrinked. Sorry, not the total piece, but the free has shrinked, of course. So now the total size is the same, of course, but now the free is only 74, while the allocated is now 50, which means our 200 megabytes of logic volume needs 50 physical extents to actually create this logic volume. The rest is available, of course. Again, do a VG display to see what's in our volume group. Now again, you see the volume group has the same total size, but with the same allocation, of course. 550 is allocated for our logical volume, while 70 are still free. And now we should see also a logical volume, LV display, logical volume display. And here we are. This is now our logical volume. This is the name for this new volume. Couple of informations. This is my size, 100 megabytes, 50 logic. In this case, it's talking about LEs, the logical extent, which is more or less the same as the physical extents. I only call this LE at this level. So we have this 50 blocks, and the rest is only not that important. And now we have a new block device, and this is a new block device which can be used the same way as before, but with the advantage of moving, resizing, and everything what we'll see in a minute. Now what we do in order to access or to bring a file on it, we could, if we want, partition again, which really makes no sense. We could do this, but we simply jump in with step numbers 3 and 4. We directly format this thing and mount it. So it makes no sense to create another partition on it. So because it's a simply new block device. So now let's format this thing with the same command. Remember, the command was mkfs, make file system, mkfs, and then I use the type ext4, which is the default, and I use this newly block device. And then again we have the same output. It's created a new file system with a couple of inode blocks, and then we can mount it again. That's the same command as before. We now mount this logical volume on the same place as before. Mount the name. Remember, we use /data for our mount point, and here we are. We have mounted our file system. Let's have a look at this directory, ll-data. Now you see again this lost and found. It's very common for a root directory. When we use the command df, we see, okay, on data we have mounted this def mapper. This is simply another name because there's a mapping level involved to convert this logic volume in with using a mapper to block device. But you see, this is our logic volume mapped to this data subdirectory. So it gives us a number of used and free blocks. To make this a little more human-friendly readable, I normally use the option -h for human-friendly output. And then you see the size. What we can use there is 158 megabytes. Of course, we created a logical volume out of 200 megabytes. But of course we cannot use all the space for the files, because the file system itself needs space for allocating the directory structure and everything else. So it's always a bit smaller than the actual size. But now we can bring a file on it. So we can go to our data directory, bring in our hello world file, hello world to test.txt in our directory test.txt, and here we are, we have our hello world file. So that's it for the basic setup of a logic volume manager. Bring in a new block device as a physical volume, create a volume group, if not already existing of course, create a logical volume, and then format and mount it. Now what's the advantage now? Why this extra overhead? Because now we have the same as before, we can place a file on it. And now of course the big advantage is that we can actually resize it, we can mirror it, we can snapshot, we can move it. This is all the basic option what we can get. So in the next episode we will then see how to increase the size or even add a new disk if the first disk runs out of space.